In this lecture, let's move the player with the agent component. So far, we have access to this component. If you were to look through the documentation, there's a method for moving the agent called move. Currently, I am viewing the documentation for this method. According to the documentation, this method will move the agent from its current location. The most important piece of information is the parameters section. Under this section, we can pass in values to customize the behavior of the method. There's one parameter, which is a vector 3. We must provide this method with an offset for moving the agent. Luckily, we happen to have such a value. Let's open the movement file. Below the awake method, define a private method called update. The update method is another lifecycle method. It's similar to the awake method. Unity automatically calls this method. So, what's the difference? The awake method gets called once, which is upon the creation of the game object. The update method gets called on every frame. For example, let's say the player's monitor rate is 60 FPS. This method would get called 60 times a second, so on and so forth. But why are we using this method? Players should move smoothly. If we were to update their position in a single frame, the movement would look awkward. Movement should be incremental. For this reason, Unity adds the update method to help us create smooth movements. Inside this method, run a method called movePlayer. We're going to outsource the logic for moving the player in a different method. Technically, we could define the logic from this method. However, it'll be cleaner to split our code into methods. Let's define this method below the update method. It'll be private. Inside the movePlayer method, call the agent.move method with the movement vector variable. Let's quickly discuss what will happen. The move method will move the player from their current position based on the offset passed in. The player's position is saved as a vector 3. For example, let's say the current position of the player is 10 on all axes. Next, our offset is the movement vector variable. For this example, the vector is 1, 0, 0. The move method handles adding both vectors together. The new position becomes 11, 10, 10. However, there's more to it than that. The move method performs additional checks. Firstly, it'll calculate the new position. Before moving the game object, it'll verify that the new position is within the bounds of the navigation mesh. If it is, the object is moved to the new position. Otherwise, the new position is rejected. By using the navigation components, we can avoid performing these checks ourselves. Let's try testing our work. In the Unity editor, let's dock the game and scene windows side by side. Currently, we're not able to view the player with the game's camera. In a future lecture, we'll update the camera to follow the player. For now, we must view the player's movement through the scene window. Let's press play. As we press the WASD keys, the player is moving. We move left, right, forward, backward, and even diagonally. Thanks to the AI, we're not able to move outside the map. If we were to bump into walls, the player cannot move past them. That's great. Admittedly, the speed is extremely fast. That can be fixed with additional code. If we look at the console, the movement vector variable continues to be logged. I'm going to quickly clear the console. Next, I'm going to move right without releasing the key. In the console, the movement vector variable has been updated to 1, 0, 0. While it's set to this value, the move method constantly attempts to move the player. The moment I release the key, the vector gets reset to 0, 0, 0. But why? The input system will automatically reset the vector after the key has been pressed. This behavior works in our favor. We want the vector to be reset. Otherwise, the player will constantly be moving. Once the vector is reset, the move method will not move the player since the vector is 0. Everything works beautifully. In the next set of lectures, let's begin refining the solution by following the player with the camera and slowing the player's speed.